So one thing that we need to understand before we can really talk about collecting data is to understand randomness. So we're going to talk about an example. So a game I play with my daughter Quinn is called Cootie. And I have a little picture for those of you that have played it before, and to give you an idea for those that have not. But in this goal, basically your bug is not built. There's just parts to a bug, and you try to build your bug based upon outcomes of a die. So for example, you roll a 1, you get your body, you roll a 2, you get your head, you roll a 3, you get your eyes. So based upon what you roll, you get certain body parts for your bug, and your goal is to be the first person to build your bug. So one thing that is true in this is our die rolls are considered to be random. So why do I actually want my die rolls to be random? Why is that a good thing? So the die rolls being random allows us to believe that the game is fair. For example, my daughter is 7. I'm older than that. And age is no advantage at all. So basically, everyone has the same chance of winning. So we like that. Things are fair. So just thinking about what you know about a die, and I'm talking about a 6-sided die here. What would you expect to see if you were to roll a die 60 times? Just think about what would you actually expect. Well, so there are 6 sides. So I'd expect to see 10 of each side. So I'd expect to see 10 1s, 10 2s, 10 3s, 10 4s, 10 5s, and 10 6s. I forgot that's what I would expect to see. So something to think about here. Even if the die is fair, so it's perfectly balanced, will this happen every time I do it? So every time I roll the die 60 times, am I going to get 10 1s, 10 2s, 10 3s, 10 4s, 10 5s, and 10 6s? Not necessarily. I could, but I'm not going to necessarily get that every single time I do this. We can get something different. Right? Well then, okay, so if we can get something different, how different is still okay to believe the die really is fair? So how different can I get from having 10 of each of the 1, 2, 3, 4, 5, and 6 before you're going to say, I don't think the die is fair anymore? So how different can I be from that? Well, I'm hoping this is partly your answer. It sort of depends. Right, if I get 8 1s, that's not that different. And if I get 8 2s, that's not that different. If I get 8 3s, 8 4s, and 8 5s, that's maybe not real different for those, but then what that just means as well is that I got 20 6s. Right, so some of the numbers weren't very different, but one of them was, right? So kind of how they're distributed makes a difference to me. But another thing that really helps me want to decide here is, well, how many times am I doing it? Right, so 60 rolls is one thing. And when we're talking about number of rolls, this is sort of what we're referring to as our sample size, like how much data am I really collecting here. If I only roll it twice and get 2 6s, I might not be really that surprised by it. But if I rolled it 10 times and got all 6s, that's going to be a little bit different to me. So that's going to be one of our goals, is figuring out, here's what I expect to see. Here's what I got when I actually collected my sample. And is it still okay? Right, that's going to be one of our goals. At what point would you say the die is no longer fair? So random outcomes actually do provide a lot of structure for us and give us an idea of what to expect. So because of knowing that they're random, we know what to expect. Right? I knew exactly what to expect. Even though we were saying the word random, I still know exactly what to expect to see. And so I can take this and I can compare what we get from our sample to this. Right, how different is what I got from my sample to what I expected to see? And that's one of the big goals that we have in statistics. Here's what I expected, here's what I got. What kind of decision can I make?